All right, I think we've had enough time to wait. So let's go ahead and do some introductions and say hello to everybody. Hello, everybody. Thank you very much for coming out this afternoon for our, or morning for some of you, for joining from anywhere west of my time zone, which is Central Time. This is the structural interface and for automated compliance checking workshop from our panel project over the last year, conducted between SSI and Auros, primarily from the technical aspect with our shipyard partners, who we'll all see that in just a few moments on some slides coming in. For those of you that don't know me, why not? But if you don't, I'm Pat David of ShipConstructor Software USA down here in Mobile, Alabama. And on the line, if you guys are looking at the little tiny video bubbles, we have from my office also Eric, who is video muted and should stop that. Or AKA turn on your video. There's Eric. This is Eric Bjorkner from my office in the US office, so those of you that haven't met him. And yeah, so that was SSI ShipConstructor Software USA. And from Auros, we have our, again, if you don't know these guys, I don't know how you don't, but you'll have Greg Burek just below my head on my screen. Say hi, say good night, Gracie.
Hello, everyone. Greg Burke, Auros Knowledge Systems in snowy Michigan.
Yeah. And we also have Steve Boisbert from Auros, also from snowy Michigan, I think.
No, actually, it's not snowing in my neck of the woods in Michigan, which is nice. So Greg can keep it.
Oh, fantastic. So what we wanted to cover, I think, let me see what I have for slides. Let me see if I can move my slides around. There we go. So these are the normal NSRP ATI antitrust rule slides that Nick, Laney, or Carolyn would normally speak to. I don't care. I'm happy to talk to this if you want, Nick, or do you want to let us hear the sounds of your dulcet voice this morning?
You can hear it for a short time, but I think we should appreciate yours. So as long as you hit those big ones on top, we're good.
Oh, good. Okay. So as usual, antitrust rules during our workshop regarding our companies and or any of our competitors. Don't talk about prices at all. Just leave that off the table. It's not really a good idea. Don't talk about any procedures or policies or stabilizing prices or standardizing. Don't discuss anything around controlling or allocating the market information. This is all SEC stuff, by the way. And don't discuss any future work you're going to be doing or any marketing strategies you're going to consider. This is all to keep us all on the up and level with the Securities and Exchange Commission. Don't talk about refusing to deal with a company because of their awesome mustache or distribution practices. And don't discuss any plans to award business to any specific companies for any specific reason. And any trade secrets, don't talk about them. And if you do, you're going to get us all in a lot of trouble. So don't start talking about that stuff. So these are all the antitrust rules that we have to make sure everybody's aware of ahead of our meetings so that the SEC stays happy. Just so keep that in mind if you have any comments or questions that are coming up. Our agenda for today is our kickoff, which you're seeing right now, which is the welcome and the project overview, which I'm apparently doing along with the ShipConstructor overview. Good stuff. And I'll follow that up with Won Min Moon from the American Bureau of Shipping, who will give us an ABS overview. If you don't know ABS, again, how do you not? And then we're going to kick into Auros at 2 to give us an overview about what Auros is for those of you that have not had an opportunity to work with the wonderful folks at Auros and see what the knowledge provisioning system is that they have and that they've been working with a lot of projects over the past few years on. After that, we're going to talk a little bit about what the prior work was that we had done, the stuff we've done previous years. And then we're going to get into a conceptual overview of what that Auros to CAD connector is, you know, kind of what the intention is and at a high level, how it's going to happen. And then we'll have a look at use cases that we are investigating in it. And you'll have a look at the actual work that has been conducted so far that Steve and his team have just knocked out of the park in terms of those integration efforts. And then we'll take questions, and then we'll close up, and then we'll have a happy hour. So for, I'm gonna look at this for myself. This is the first time I'm seeing this slide. Okay, so 1 minute, 1:45. I'm just gonna go until 1:45. Oh, you guys have such an awesome 40 minutes ahead of you. The overall objective of the project was for us to have a means for streamlining. You don't have to read this, I can just explain it. We wanted to streamline our compliance checking with regulatory bodies by including any of the information from the 3D design model, doing compliance checking against any rules that may be that we parsed from the regulatory bodies, in this case ABS, and allow that to be used as a means for conveying that information to the regulatory body. You know, hey, here's all the normal drawings that I might produce for you for a rule check according to the ABS rules. Here's where that had been checked against the 3D model, and we verified that this, you know, it was good then. And communicating that information to ABS, right? So we wanted to automate that as much as possible. So any structural detail design that was going on inside of the 3D model, we wanted to be able to say, you know, these plates require a certain kind of thickness, or there needs to be a certain stiffener spacing, or, you know, pick your rule from ABS. And is the thing that's in the 3D model here in compliance with that rule? And to kind of streamline that, you don't want someone to have to go through, query a bunch of numbers, plug them into a formula, jot it down in a notebook, and then make a note in a PDF or in a title block somewhere in a drawing. You'd like that to be integrated in some way because it's 2021. We're smarter than that. So that's one of the goals. The other one is, of course, a development roadmap for that connector, that the thing that ties the 3D design environment ShipConstructor with the knowledge provisioning system from Auros. And where do those two things meet? And how do we pass that information back and forth between those things? And then be able to provide that information to ABS in a way that they can verify that those rules were in fact checked, and have built confidence in the system that it's telling them what they need to know. And I mentioned it earlier, but our shipyard partners on this project were FINCANTIERI, Marinette Marine. I think Charlie Jackson's probably on the line. If you haven't met Charlie, why not? Great guy, a lot of fun to hang out with and chat with. We also have, oh yes, who's this?
It's Charlie.
Oh, yeah, see, there's a Charlie right there. Say hi, Charlie.
I did. Hi. Hi, all.
No, well, there you go. So there's Charlie. We also have Conrad, my friends over in Louisiana. We have Renee Leonard and Sean Hunter. Were on this project as well for us. I don't know if they're around, but by all means, say hello, gentlemen.
On the line right now.
There we are. Hello, Renee. So those were our shipyard partners, and those guys were kind of crucial to getting some understanding of what that, what this project was going to impact and how it could be used at the shipyards, especially important when it came to use cases. And then we have our ABS partner for the regulatory bodies. I think he was on briefly a moment ago, but One Min Moon is here as well, kind of feeding us information from the ABS side and making sure we were staying on top of things. SSI, we already talked about. I'm here. Eric's here. I think Jason Rencourt is supposed to be on the line, but he's our primary development liaison up in our Canadian office, the home office of the company. Auros had, oh, hi, Jason. We also had Auros. You guys have met those guys, but Venkata and Sandip were also instrumental in doing a lot of that programming and development work on the back end. And then, of course, a normal NSRP project team guys. I think Virgil may or may not be on the line. Virgil, are you on the line? Virgil was our PTR on this project. He may be unavailable right now, or he's muted. Technology's hard, isn't it, Virgil? He's not here. So I just wanted to, I think I have some slides that talk a little bit about who SSI is. If you're not familiar, I apologize if you guys are already familiar with who I am and who Auros is, and you're tired of me constantly talking about us. But there may be people on the line that aren't familiar with who these companies are or what they represent. So I just wanted to give kind of a brief overview of SSI so that those people can have an understanding about who we are and where we came from and what we're doing and what we're all about. SSI started back up in '89 as Albacore Research. This guy named Rolf Otter did this at the University of Victoria once upon a time. We basically are known primarily for our ship design, product design system, ShipConstructor. So our headquarters is up in Victoria, BC. I opened this office in Mobile, Alabama with another Pat Cahill back in 2006. Is that right? I guess that's probably right. Right-ish. So, and mostly so we could service clients on the Gulf Coast. We had a lot of users on the Gulf Coast and needed somebody, right down in here. We've also got offices in Singapore, India, and pick your poison. Anywhere where someone's trying to hack together a ship, chances are we're going to spring an office up there and try to get them to use ShipConstructor. So there's a lot of other stuff on there that's not really all interesting to talk about. I love graphs with no real numbers. We have growth. It's just a curve. It goes up. We're growing. Yay. And institutions, I'm not sure what that means. We have more than 20 institutions. That's what it looks like anyway. Lots and lots of licenses though. We ShipConstructor also enjoys a rather large number of users. We have a huge user base that expands all across the industry for shipbuilding, particularly in North America. We've always had a pretty robust R&D investment. For anyone that's ever done any NSRP work, you probably are tired of seeing my face and hearing me talk, but we've done a lot of stuff with shipyards to try to address what their needs and problems might be. Global clients, we have lots. That's what that pie chart looks like. Lots. I'm sure we can go in there and figure out what those lots numbers are, but you get it. We have lots of clients all over the place, but we have been in business for 30 plus years at this point, providing all kinds of wild and crazy tools for the shipbuilder. We are global. I think I mentioned that earlier. You can see our little gold marker for the Canadian office down here in the Mobile, Alabama area, which is where I'm currently calling you from. Which we opened up a while back. We have partners up in Canada, in Brazil, Spain, Middle East, India, Singapore, Australia. We're all over the place. We got somebody somewhere doing something all the time. The sun never sets on SSI. And ShipConstructor as a product, if you're not familiar with it, it's really kind of like this product design model where we have the philosophy of producing information in the ShipConstructor model that should theoretically mirror what the physical object is as a delivery at the end of the day. Whatever that ship should look like, and whatever it needs to be made out of, and whatever it needs to be formed, beaten, welded, or bolted together, we want all of that information in the ShipCon model. So we do handle things like some initial design work, but in the design world, that basic design is kind of the basic and detailed design are really kind of the meat potatoes of what you'll find in a ShipCon model. But from that information, once we've modeled it, we are also producing all of the production material information required for manufacturing that object, right? So this includes all of the preparation stuff, the stock catalog, stock information, number of plates, heat numbers, nesting information, all of the normal shipyard process work that goes into producing the individual components and making those individual components that we then assemble into the ship structures as we build it up. Those first two are huge for us at the moment. Maintenance is something we have done in the past a little bit, but have begun more and more to consider in a broader sense. And this is assessment and management of maintenance of vessels, especially for repair and refit work as we go on. And they've also released a sister product called Enterprise Platform, which is a means for accessing data from the ShipConstructor product model to feed other business systems and business units as needed, and to automate some of those tasks that you would normally do on a day-to-day basis. That is a marketing slide if I've ever seen one. Hang on, I have to figure out what it says. Well, the core of some of what we've been driving towards lately is kind of this shipbuilding product lifecycle model concept, where the information and ShipConstructor model stuff that happens in engineering and it feeds into production, has to coincide with things like production planning, scheduling, supply chain work, and procurement work. Why is procurement different than supply chain? Anyway, so with the base ShipConstructor model, we have a representation of what the product is going to be. Then things like Enterprise Platform and this digital hub, I think they probably put information hub, whatever buzzword they decided to stick in there. Really what it means is that we have a layer for business logic to interact with other business units to coordinate that information. So if I know I need a bunch of things to manufacture an assembly or a component at a particular date based on the planning and scheduling, I can feed all that information back up the supply chain stream to make sure that I can support things like just-in-time delivery of material and components to support the production process, and ops and IT, things like that. And then, of course, the downstream of this is once we've built and delivered, we theoretically can provide either the model or management to the owner operators for fleet management or sustainment later on. And that's kind of where that PLM nugget ties all of that together. This just says we have lots of products. It's, you know, in this project, we're focusing on the structure and structural modeling, but we do quite a bit more than that. You know, we also do piping, HVAC, electrical, so outfitting systems, distributed systems, equipment, you know, penetrations. This is all kind of in the modeling and design work of this. Nest and NC Pyros, for example, are kind of fabrication production tools. Work share and report or purely reporting information, Ship Explorer and some other things. So we have a full suite for the ship design and product modeling requirements for a modern shipyard. And we've done lots of stuff. I've known Rolf, who was the owner and founder of the company back in the day, probably since 2001, I want to say, which is really when I started kind of working on it heavily. So, you know, down at Bender Shipbuilding, which is actually the shipyard where I started working, way back in the day, doing offshore supply vessels and platform supply vessels, that's what OSV and PSV mean down there. And then did that for a decade, right? We did a luxury vessel with Trinity Yachts in '95 and had expanded to other luxury yacht market as well. Got into the first defense project in the early 2000s, working on, he says, first offshore project. I'm guessing that is actually a reference to some jackup rig work and not specifically a ship or a vessel in that sense. And some fast various combat vessels, but basically we've been in the industry for 30 years, so we've had a large number of our clients building all sorts of ship platforms over the years. So that is an awful slide. I apologize. That looks like a history of R&D, a sampling of R&D project work from past projects that we've done at SSI. So, the ship design tool enhancement 1 and 2, I actually wrote that project back in 2003. I think I wrote that back in 2003, but I'd have to go back and double check. It might be 2004, but that was ages. I feel like a long time ago. Anyway, over the years, we've been involved in lots and lots of stuff. And, the cool thing about all of these, I should probably point out, is that in almost every single case, this has been something where a shipyard has come to us and said, hey, I'm having this problem. Do you have any ideas for how we might be able to address it, right? The computer-aided robotic welding was, hey, we think we'd like to get into robots to weld these things up. Can you guys support that? I have no idea, but we can try. So we did the CAR-W project back about 8 years ago or 9 years ago, something like this now. Modern shipbuilding design, creating coursework to help train people, production planning, integration. You can see the wide range of project types that we've been into over the last 15 years at SSI down here, something like this. And I think that's apparently all I have from an SSI side. Did I finish early? Oh my gosh, I finished early. Look at that. I don't know, gentlemen, should we be taking questions as we go at all, or should we just go ahead and slide on into 1 min and let you talk about ABS? Going once, going twice, going 3 times. I'm going to default to letting 1 min. You're up to bat.
Thank you, Patrick.
Now.
Hello, everyone. My name is Won-min Moon, a manager in ABS Digital Engineering team, working with Dan Cronin, Vice President of ABS Standard and Digital class. I hope he's going to attend this meeting soon later. I'm very excited today being allowed to work it through with a quick introduction of who we are, ABSS Classification Society, and our brief history and our current global network. I'm going to quickly introduce our recent custom rulebook project that we are planning to deliver the customized set of ABS rules and guides based on our clients' demands, such as for a particular vessel type or ABS notation. I'm also going to introduce our digital revision that ABS and Auros have been collaborating for a while. Patrick, next slide, please. We, ABS, is a not-for-profit organization in the shipbuilding and offshore industry, establishing and maintaining technical standards for construction and operation of marine vessels and offshore structure. The primary role of classification societies is to classify ships and validate their design are in accordance with published standard, which is ABS rules and guides. We carry out the new construction and periodical survey of the ships and offshore structure to ensure that they continue to meet the parameter of safety standard. I would say we are one of the stakeholders in the maritime safety network, together with many shipbuilding companies, like many of you who are attending this workshop today, and ship owner and flag state under the marine safety regime. Next slide. ABS was first chartered in the state of New York in 1862 as the American Shipmasters Association to certify ship captains or shipmaster for safe ship operation during the Civil War. While ASA's certificates were not an official requirement for a shipmaster, the certificate served as a recommendation for ship owners. Vessels that sailed with a certified ASA shipmaster were more likely to find favorable insurance coverage. The ASA published its first technical standards rules for survey and classing wooden vessels in 1870. In the late 19th century, wooden ship became obsolete and gave way to iron as a shipbuilding material. In response, ASA published its first rules for survey and classing of iron vessel in 1877. Similarly, when iron gave way to steel, ABS rule for building and classing steel vessel rules were established and published in 1890. These steel vessel rules have been continuing revised and published annually. As business shifted from the certification of shipmaster to classification of ship, American Shipmasters Association renamed itself the American Bureau of Shipping in 1898. Next slide, please. The ABS World Headquarters is located in Spring. Previously, we were in Houston, but it's pretty close to each other in Texas. ABS is currently organized by market sector, global marine, global offshore, and government service. There are over 5,500 employees worldwide. ABS surveyors and engineers work at major ports and more than 200 offices in 70 countries worldwide, including Houston, Singapore, London, Shanghai, Busan, Yokohama, and many other cities. Patrick, next slide, please. We do have the integrated closed-loop process to establish our rules, guides, and guidance notes, which are being considered as recognized technical standard by most of the flag state. For vessel built to ABS class, ABS engineer must approve the vessel design during the engineering review in accordance with our rules. After design approval, ABS field surveyor attend the vessel at the shipyard from the keel lane to the delivery. During the construction of the vessel built to ABS class, surveyors witness the test of material for the hull and certain items of machinery as required by the rules. They also survey the building, installation, and testing of the structure and principal mechanical and electrical system. We carry out the periodical survey of the ship and offshore structure to ensure that they continue being maintained to the accepted safety standard. Any findings or recommendation through the life cycle of those assets classified by ABS will also provide the feedback to us to enhance and up-to-date our technical standards and safety requirements. Next slide, please. We currently have 14 rules and more than 140 guides published and being maintained biannually or as necessary. Rule is more about the mandatory requirements to classify the vessel in ABS, while guides are being developed as the requirement for the optional notation chosen by our clients. Guide is more effectively under frequent revision and considered as preliminary rules. It also often become consolidated into our rules when we consider they are enough mature to become our rules. You may have heard of ABS Custom Rulebook project, which was selected for NSRP research announcement for 2021, but unfortunately, it's decided to indefinitely postpone the award. Even the NSRP funding this year was withdrawn. ABS has already started the development of custom rulebook project to deliver the customized set of ABS rules and guide. Currently, in order to find the applicable rules and guide, our client has to spend good amount of time to research and shop in our bookshelf publicly available in ABS website. But this project will deliver an application to generate ABS custom rulebook to be made available gratis to industry stakeholders. This will further simplify the regulatory compliance workflow by providing customized ABS rule set that contain only the rules and guides very specific to the vessel being designed and built, or even based on the shipyard discipline, avoiding the complexity of overlapping or ambiguous rule sets. So the outcome of the custom rulebook project will include the rules and guides based on the vessel parameter, such as vessel type, vessel function, and class notations. Next slide, please. I can't emphasize enough that ABS rules are at the core of our business. In addition to the custom rulebook that I have just introduced, and we also have been collaborating with Auros to offer a tool to make it easier for shipyard and designer to manage the ABS rules and other requirements by putting them in a tool that actively delivers them to the engineers when they need it as they work. Believe in the future, ABS requirements will be more tightly connected to the design environment. As a result, teams will be able to work more efficiently, eliminate the need to look for the technical know-how and standard, and always work on the most up-to-date rules and standards. Here are 3 tiers of this digital rule vision. Tier 1 is requirement management, and Tier 2, calculation routines enabled on top of Tier 1, and Tier 3 is connected to a CAD environment. You can see the listed several of the CAD systems that have been already connected to Auros, and also the SHIPCONSTRUCTOR that we are going to discuss today. Next slide, please. Here is an example of Tier 1 assessment control. I believe Tier 1 is a pretty significant milestone that we have already achieved through the working with the Auros so far. So Tier 1 tool is now available as a converter, which can automate the process of converting ABS rules and guide into the Auros knowledge packets. Tier 1 tools automate the provisioning of information to utilize during the design or design review process. The goal is actually to provide digestible information at the exact time that the engineer needs to make a design decision or perform the engineering activity. The example here is a collection of knowledge packets populated with ABS rules and makes up a smart checklist. The rule can be viewed by clicking the KPAC link. Once complete, the evaluator would mark it as complete, or command can put the command in the notes. These assessments can be configurable to a shipyard process or project. Again, tier 1 is more like to deal with the text-based contents. Next is text tier 2. This is example of the tier 2 knowledge packet. In addition to the text-based rules, some executable equations are also enabled so that designer can calculate the requirements as they move through the CAPEX. You know how many times the vessel length, blast, depth, or such a principal values are entered by different people for different purpose in order to calculate different structure prescriptive requirement. So through this tier 2 product, information can be shared so that certain parameters do not need to be entered multiple times by multiple different people. There are a lot of prescriptive formulas in ABS rules so that engineer or designer need to create and maintain their own spreadsheet to simply calculate these requirements. But those in-house spreadsheets can be easily out of date if the engineer is not aware of the updates of the ABS rules. But Auros knowledge packet has a capability to seamlessly update any formula based on rule change or ABS rule updates. Last slide is about tier 3. So finally, tier 3 tools include CAPEX with executable equations and also can be linked to a CAD model. While the SSI and Auros since last year, we have been identifying a lot of beneficial use case such as global or local section modulus calculation from the 3D model and some of the plate thickness and stiffener scattering requirement with a given frame or stiffness spacing. We've also investigated how we can verify weld lag lengths based on ABS rule requirement just by clicking one button to verify the required welding lag length or welding size, something like that. So we believe this is also a very powerful tool that can allow a user quickly evaluate the change to a sister or some similar vessel design. So having said these 3 tiers of our ABS digital rule vision, I believe our digital rules will significantly reduce the non-value added time the engineer spends research, retrieving and vetting the usable information, and also reinforce the use of standard engineering process and shipyard productivity standard. Eventually, we hope it can facilitate a faster turnaround for ABS when ABS certified CAPEX are used and the result of CAPEX rule checks can be submitted to ABS preliminary review. That's all about I have today.
Awesome. Thank you very much, Won Min. I really appreciate it.
Thank you.
Thank you. Thank you. Hopefully that gives you a nice overview of ABS. And then there's a big chunky overview from our friends at Auros. I don't know if it wants to be Greg, maybe?
It is Greg.
It is Greg. Well,
It
then
is
I'm
Greg.
going, you just scream next slide into the microphone if you need me, if I don't pick up on your cue to swap slide. So
I will certainly do that. Thanks, Pat.
sure
So
thing.
first, good morning, good afternoon to everyone, and thank you for joining us for this this workshop. Hopefully you find it interesting and valuable. So I'm a director at Auros Knowledge Systems. I'm specifically focused on maritime systems. And Auros Knowledge Systems is located in Livonia, Michigan. We're about 15 miles west of Detroit. The product that we produce, our software product for knowledge provisioning and knowledge awareness, is titled Auros IQ. So sometimes it causes a little bit of confusion. So the product itself is Auros IQ. Our company, we have development in other countries as well, in the Ukraine and in India. And we have service partners located in France, India, and China. So the genesis for Auros or Auros IQ really goes back to the mid-1990s. And it started at Ford Motor Company. We, like many companies in discrete manufacturing, struggled with the concept of reusing knowledge that was being learned on the factory floor, in warranty, in the design rooms. And like all other companies, we were very good at collecting all sorts of knowledge and all sorts of data and all sorts of information. And then we would bookshelf it and put it away, and it would not be seen again until somebody has another problem just like it, and they would go after it. So the real challenge that we had was to figure out how to not just collect knowledge and think of reusing it as an afterthought, but mainly focus on the concept of provisioning knowledge to the engineers, to the construction, basically to any decision makers at the time that they need that information. And we termed that concept knowledge aware. And it really, again, grew out of not only the need to deliver knowledge, but it was also a result of something that we were working on in the mid-90s, which was knowledge-based engineering. As most of you probably know, that is a product, a software product that creates or builds 3D CAD systems based on rules. And I think, Pat, we're on, yep, there. Thanks. So what we wanted to do was somehow, we had developed knowledge-based engineering applications, but we quickly found out that it was very difficult to maintain those, because if you had to make a rule change, you'd have to have a programmer program those rules right into the CAD software. So we came up with the concept of a discrete knowledge base that would not only represent knowledge in textual form, but also in digital form, so that it could be driven into digital tools to allow us to support model-based engineering. Next slide, please. So, as I mentioned, we grew out of the automotive industry, and we have a very large footprint in the automotive industry. We support from start to finish in Ford, General Motors, Fiat Chrysler, but we've also grown into many other industries. We found out that basically the challenge of delivering knowledge when needed is one that's shared by all industries. And the patterns are typically the same. There are some differences, but we've successfully grown to well over 40,000 global users that are currently using Auros IQ. Next slide. So let me talk a little bit about what knowledge aware or what knowledge provisioning is. And we use the concept or the analogy of maps and versus navigational systems. If you think back 10, 15 years ago when someone was traveling, they would typically get a paper map and mark out the distance that they wanted to go or the location they wanted to go, look for the best route, and off they went. The problem with that approach is that it basically mirrors the legacy document management approach to knowledge management that existed at the time as well, and currently still exists. Those knowledge that the maps themselves are static. It's a hard copy. And once it has been produced, published, printed, it immediately goes out of date. If there's a change to a road, if there are new bridges, anything that might impact the information on that map, the user of that map has no idea that those changes exist or those how to react to it. The other thing is that it's impossible or very difficult to use. You typically have to have a navigator. So you're following the map, you end up taking a wrong turn, and You can't just automatically get right back onto another route. You have to pull over, study the map, relearn where you want it to do, because all the information that you need to get to your location is in essence delivered to you all at the same time. You've got a map, it's got all the turns, all the roads there, and you've got to figure out where you're at and how to get there. Compare that to our current GPS systems. They're dynamic. Obviously, they're very easy to use, and the directions are provisioned to the driver as they are needed. We also have the ability of, through GPS, to update the mapping system based on changes, because it's digitally connected to the systems that know about those roads. The other thing is that through insights that you're receiving from other drivers, you become aware of things that are happening today that give you a better idea. So if you need to take another route because there's a closure or a backup, that information is available. So the difference between the two is how we try to explain what knowledge-aware knowledge provisioning is. The individual bits of knowledge that you need are delivered to you at the time of need. Next slide, please. So taking that back to knowledge-aware, what we do with Auros IQ is we have, you've heard the term knowledge packets. These are in essence elementary units of knowledge that have been stripped out or combed out of documents, rules, learnings that might occur on the plant floor. And they're very specific, very unique to a specific bit of knowledge. So you can see on the left-hand side here, we show a cartoon where you take these document-based systems and convert them into digital knowledge packets that are on the ready to be delivered when they are needed. On the right-hand side, we have the concept of assessment controls, and that you heard Juan mention those as well. The assessment controls are a technology that is part of Auros IQ that is in essence a live, dynamic bucket that has a search routine that's constantly being updated with new packets or changed knowledge packets that are focused on a particular subject or topic. So for instance, for someone that's working on structure or possibly looking at ABS rules for a particular area of the ship, the assessment control has the ability to, using agents, to constantly bring in any new knowledge packets that are relevant to what that individual is using. They're delivered to the worker, and then the worker or the decision maker, the knowledge consumer, responds and indicates how they've utilized that knowledge, whether it's been in compliance or not in compliance. If it's not in compliance, it allows you to capture the reasons why you are not in compliance and what the alternative is for. Next slide. So going back to the map and GPS analogy, the knowledge packets really are those tiles that pop up and give you the specific turn information, where you should turn, when a turn is coming up in the next, mile and a half. You can think of those as a knowledge package. Each one, again, is an individual bit of knowledge. The actual screen, which is used to deliver that information to the consumer, you can think of that as the assessment control, because as I start, I entered in an assessment or an address. Based on that address, it delivers and lines up the knowledge packets that I will need at the time that their need, and then they will be delivered to me as I progress through my process. And again, if I end up making a change, or there is a change in the system because there's a backup or a road closure, the assessment control is constantly looking for those changes and pulls them up and then delivers that new knowledge to me as a driver. So that's basically knowledge aware. So Pat, the next slide, please. So within Auros IQ, there are three critical fundamental enabling technologies. The knowledge packets, which I've talked about to a certain extent. And I have a couple more slides that will show you a little bit more information on that. But that's in essence the core, the unit of knowledge that represents the collection that a company or a system or an enterprise maintains. And each knowledge packet has, I call it a wrapper of information. It knows about itself, so it knows where it's applicable. It's got tags that knows it, whether it's applicable to plastic parts or if it's applicable to doors or to the hull or to steel. Anything that you as a knowledge consumer can identify as a need, you can add that as a tag to each knowledge packet so it knows when it's required. On the right side are the assessment controls. And again, I'll make a few comments about that later, but Steve Boyser will give you a much clearer and more defined explanation of what assessment controls are. The rule processing engine is embedded within Auros IQ, and this is what allows us to take a knowledge packet and compare it to things within a CAD system, process that rule and compare it to the actuals within the 3D system or the 3D model and determine whether or not we are in compliance with the rule or some other thing that it might be required. So next slide, please, Pat. So this here represents what we've been doing with specifically with ABS. ABS is one of the areas that we focused on, and we have gone in and developed a translator that reads in. Can you go back a couple, please? And reads in basically the rule book and breaks them into individual knowledge packets based on certain criteria. All right, the next slide, please. And this represents how one specific knowledge packet that may have resulted from this document. And in it, you can see that there's a description. There's a description of the knowledge packet. There's additional information. There is visual information. You can have video, you can have audio, all sorts of information that helps explain and define what this rule is. But down at the bottom is the represents a value table. That's what we use to capture and to model an individual rule that can be modeled digitally. And that is what's run through the rule processor to compare it to the actual design. All right, next slide, please. So the benefits of knowledge provisioning, these are five that I chose because I think these are some of the most significant. The elimination of recurring mistakes. So whether it's done through a 3D system or whether it's done by delivering critical knowledge to a designer as he or she is working on a design, because you've captured possibly learnings from warranty systems in the past or production issues that you've had and turned those into knowledge packets, and those knowledge packets have been tagged and identified for where they should be applied, you can guarantee that things that have been used in previous years can be delivered to individuals that need to know that at this point in time. Obviously, you're preserving the knowledge that's being captured. And because it is an enterprise system, that knowledge can be delivered to many different locations through many different channels. You have an improvement in the workforce efficiency because now you're enabling an engineer to proceed with the design, making decisions without the need for searching and going through books or going through libraries and downloading documents and then looking through PowerPoint slides and figuring out what elements of that presentation or that final report are really applicable to his or her particular situation. It's a much more efficient approach. We have a reduction in undesirable project variation because, again, we're delivering the same rules consistently into the same system or same similar project so that there's consistency there. And then finally, one of the things that we've discovered is that we have, with our customers, have a reduction in their existing enterprise IT footprint. What we found is that there are silos throughout companies that have grown that manage knowledge, that they've attempted to implement a knowledge management system for their particular piece of the world. And it's grown into a silo. And other parts of the company have done the same thing, but they don't talk together. And they've used different types of systems. They use Excel, they use various databases, they use PLM systems. What we've discovered is that once a company is committed and used Auros IQ, they're able to eliminate those silos and replace it with a single enterprise-wide system. All right, the next slide, please. I had mentioned channels, knowledge provisioning channels earlier in the presentation, and this is just meant to represent two of those channels. So in this case, we are taking the ABS rules and we are digitizing them and turning them into knowledge packets. For the ones that are tier 1 and tier 2, those go to the left-hand side and can be used within using the assessment controls, using a web-based approach that delivers the assessment controls to the individuals and allows them to track their progress against meeting and achieving the rules and the requirements that have been identified. The tier 3, which is connecting the digitization of that rule directly into a CAD system or to any engineering digital system, is represented on the right-hand side. And that's where Steve will be giving a much more in-depth explanation of that. So next slide, please. So we've developed a number of CAD systems. We've been using it since, as I mentioned, the beginning of Auros, which was in the early 2000s, because people were interested in connecting it digitally to their CAD systems. So we have these existing CAD systems that have already been developed. We have the general knowledge connector, which is basically a starting point for implementing a unique connector. Many of our companies actually have developed their own connectors. These are ones that we've developed for some of our clients. We've also got PLM connectors that allow us to track progress and process and hang the various assessment controls along with the assembly or the components to ensure that we've captured and maintained the assessment that was used to develop that component or that assembly, so that you have traceability of how you got to the point that you're at. And this project is focused now specifically on the SHIPCONSTRUCTOR connector with a focus on the ABS rule deliverables. All right, next slide, please. So this is just one example of one of our clients that has been using Auros IQ to deliver their rules directly into their CAD system. They use NX, and they've identified the fact that it's been a significant contributor to reducing their warranty issues over the last 6-7 years. And they actually had a very large knowledge-based engineering section that what they've done now is they've taken all the rules that were developed and written directly into their CAD systems. They pulled those rules out and they now exist within Auros IQ so that they can easily change those rules as authors and drive the designs more effectively. All right, the next slide, please. So Pat had mentioned that we've had a few projects through NSRP. So this is kind of our roadmap that we've been tracking. We started in 2013 with our first project, which is technical memory management for shipyards. And in that, we did discover that there's variations and differences within shipbuilding from the automotive industry, clearly because of the size of the product, as well as the frequency and the engineering requirements, the regulatory requirements. So we took that information and made changes. And in 2018, we did a knowledge provisioning to improve first-time quality project with 4 different shipyards. And ABS participated in that. They were interested in seeing what we did. And as a result of that project, ABS and Auros worked together for the 2019 project, where we actually took a preliminary translator that was developed in the 2018 project and hardened it so that we could apply it to a broader range of ABS rules and look at actually taking the textual equations and textual representation of the mathematical models and converting those into value tables that could then be driven into CAD systems. And we've completed that last year, and then that rolled into this project that we're talking about today for automatic compliance checking to strengthen that again, so that we can get a better identification of enabling ABS to do an easier way of compliance checking. At the same time, we have another project going on right now called knowledge provisioning using AI and AR for ship repair, obviously focused on ship repair. And we developed artificial intelligence application so that we can actually take customer specifications, military standards, and regulatory requirements in other areas, scan them in and convert those into knowledge packets, and then to using AI to auto-classify them, add those tags that I had mentioned to you earlier, so that each knowledge package can be easily brought into Auros for future use. And we're using augmented reality with D'Angelo Technologies. They've developed another channel for us to deliver the knowledge packets very effectively to the ship and to the into the ship repair activity. So the next one is one that Juan Min had mentioned, the custom and digitized ABS rules, which was approved, and unfortunately, because of the funding issues, has been canceled. But we've agreed to work with ABS to look at what we can do to continue that development so that we can eventually deliver the not just tier 1 and tier 2, but tier 3 slide rules to their clientele. And then finally, we did also receive a proposal or an approval to apply the same AI to simplify the Navy standard requirements. But again, unfortunately, that one has been canceled as well, but we are looking into that and what we can do to resurrect that. Next slide, please. So I've kind of talked about processes and workflows, and you can think of it more as a value stream that's maybe focused on a specific activity. But the truth of the matter is that Auros, being an enterprise-wide system, provides what we've termed a knowledge operating system. And within shipyards and shipbuilding and ship repair, we've identified 3 major types of knowledge that are critical to the shipbuilding industry. Coming down from the top are the customer requirements. Coming from the left, we call it flow in. Those are the external standards, military standards, ABS, IMO, all the other ones that are regulatory requirements that need to be integrated along with the customer requirements as the design evolves. And then the flow up, we call that controlled crowdsourced knowledge. Those are the best practices, lessons learned that always come out of the experiences in the shipyards, operations, and the design that you want to reuse. You don't want to learn, or you don't want to lose that knowledge and that learning. So all three of those are brought in and combined into the Auros knowledge or Auros IQ database. And we call that a unified stream of knowledge because we've taken it, we've chunked it into elementary bits of knowledge, and then we have prepared it and tagged it so that it can be delivered when it is needed to the right-hand side. And then we have the flowback coming back underneath that provides the assisted learning where we're capturing. We have what we call issue clustering and knowledge clustering, and that allow us to identify where there may be voids in knowledge. So I believe that's the last one. And Patrick, FINCANTIERI. Thank you very much. I hope
Thank you very much, Greg.
I hope I
What's
didn't
that?
overstay my welcome.
Well, no. Generally, no. Sometimes a little, but no. I don't even. I think we're doing fine on time. That was Greg. That was Auros. Thank you very much. I think we have a couple of slides about our friends at the shipyards, and if we have Charlie, who said he was on the line, and it looks like he's here in my attendance. I thought maybe he'd like to talk a little bit about FINCANTIERI Marinette Marine.
Okay, hi. Good afternoon, I guess, to most of us here. Yeah, Marinette Marine was founded in 1942 as part of the growth of American shipbuilding during World War II. It is situated on 50 acres on the banks of the Menominee River in Marinette, Wisconsin, about an hour's drive north of the city of Green Bay. So Green Bay is pretty easy to get in and out of. There's also an airport up in Escanaba that's actually pretty easy to get in and out of as well. It's a town just north of us in Upper Michigan. The shipyard launches its vessels into the Menominee River, which is the boundary water between Upper Michigan and Wisconsin, and delivers its vessels to the world via the St. Lawrence Seaway. Through the years, Marinette Marine has constructed over 1,300 vessels. In 2009, the shipyard was sold to the global shipbuilding leader, FINCANTIERI of Italy. Marinette Marine became part of the FINCANTIERI Marine Group, a U.S. subsidiary of FINCANTIERI, and became FINCANTIERI Marinette Marine, or FMM. As you'll probably see, a lot of the stuff still says MMC, Marinette Marine Corporation. It should say FMM, but everybody seems to understand when they see MMC or Marinette Marine. But we are officially considered FINCANTIERI Marinette Marine. With the new ownership, the shipyard has seen significant facilities and capital improvements, making FMM capable of competing on a much broader shipbuilding market. We've had many improvements. Current improvements include the construction of a new erection building that should be able to handle our latest contract with the Navy, as well as a synchro-lift system for launching and recovering vessels from the Menominee River. FMM currently employs about 2,000 employees and draws its skilled workforce from as far away as the city of Green Bay and cities in Upper Michigan, such as Iron Mountain and Escanaba, both about an hour's drive away. FMM has participated in NSRP for about 15 years now. And then there's the rest of the stuff there on the slide that we all know how to read, so you can read that if you'd like. But I thought I'd add a little something else to that. Here's just a quick snapshot of, sample of the vessels that we've built over the years. And currently, the two current projects are on the right there, the FFG, which is now called the FFG 62, and then the LCS on the far right-hand corner. We've many vessels with the Coast Guard, WLBs, WLMs, and then the RBM response boat mediums. We are also involved with 45-foot lifeboat type style vessel, and then ferries for Staten Island. That was 15 years ago or so. Some commercial work and a couple of research vessels within the last couple of years. I've been with the company for going on 28 years as of yesterday. So my position is senior research research and development engineer, and I've been, myself personally working on NSRP stuff probably about the last 10 years now, 10 or 11 years, because I was involved with the structural marine design courses that were offered at our local university, University of Wisconsin Marinette, through NSRP. So next slide. I guess I'm done there. I don't have anything else, but thank you.
Thank you very much, Charlie. We appreciate that overview of FMM. Wow, been there for a while, haven't you?
Yes. Yes.
Conrad, I think we have a problem. I'm guessing Renee, unless you prefer to have Sean if he's on the line. Oh, sounds like Renee. Okay.
Sean is not. He was scheduled to talk to these slides, so I guess similar to you, I'm going in a little bit blind. He had put this together working with Eric. Fortunately, he had a personal matter to take care of and is running a bit late, so I'll just kind of give a little bit of overview for those who may not be familiar with Conrad. As the slide says, we've been around for over 70 years. Started with one facility in Morgan City, have expanded to now 5 yards across the Gulf South. We're still classified as a small business per the NAICS code that we're in, but we typically run around 1,000 employees company-wide. Types of products that we build, we focus a lot on the commercial market, tank barges, inland push boats, offshore tugs, deck barges, crane barges. That's kind of our bread and butter work, but we also do some government work quite a bit with the Corps of Engineers. We've probably done 25 different projects with the Corps of Engineers, variety of crane barges, dredges, push boats. We've done a series of tugs with the Army a few years back. We've built barges for the Navy. So we've done some government shipbuilding as well, and are continuing to expand our footprint there. You have another slide for us to talk to? I guess I kind of got ahead of myself, but here you can see, upper left-hand corner is a typical sort of crane barge we've done for the Corps of Engineers, a push boat there in the center. Tank barges that you see there in the upper right-hand corner, we've built literally hundreds of inland tank barges of different sizes and capacities. Ferries have been a good market for us. We've built probably 20 ferries over the year. The latest one that we see, most recent, the one in the lower left-hand corner, is currently servicing Martha's Vineyard. Major conversions, we've got a lot of, in our repair yards, not uncommon to take vessels like you see there, haul them on land. This one, I think we had the crane in the helideck, but, split a boat in half and, put a plug in the middle. That sort of major conversion is kind of standard work for us. Currently, we're building a large dredge, which is shown in the lower right-hand corner there, and a variety of hoppers and dump scows and other dredge support equipment. But that dredge is probably one of the larger contracts that we currently have in place.
I think
Okay.
that's all we have for you, actually.
That's the background on Conrad very briefly, and I don't know if there was any other intention of discussion, our involvement with the program, but it sounds like you guys have covered our participation in the actual project with some of the other slides that are prepared.
Excellent. Thank you very much, Renee. We appreciate it. Those are our friends at Conrad down in South Louisiana, which is a wonderful place to visit if you ever get an opportunity to. Gorgeous down there. So I think we are done with introductions. And I realize that some people may need a quick break to refresh a drink or maybe use the restroom. So I'm proposing maybe about a quick 5 minutes, refresh your coffee, water, soda, gin, whatever you're doing this afternoon. Use the restroom, grab a snack, and come on back. So it is 1:13. Do we want to say we meet back here at 1:20 after a short break and pick right back up?
Sounds good to me.
The only person I can see is Steve,
Sounds
and
good.
Steve seems to be nodding and so I'm going with that. So I will be back with everybody. We'll all be back here in about 6 minutes now. So we'll get some more coffee and use the restroom, and we'll pick things right back up with Steve. Well, I think it's a good time to get going again here, Steve. What do you think?
You all refreshed?
We're all refreshed. I got a new cup of water here.
Perfect. All right, actually,
I
Pat, I
think-
think you're going to stop sharing and I'm going to start sharing.
Oh, okay, fine. You don't like the way I run this thing. All right, that's totally fine. So I'm going to stop sharing. Stop sharing. Nope. And now I think you will share.
Yep. And I'm going to share.
And there we go.
All right. All right, good deal. Yeah, let me zoom down here to where we need to be. And how do I hide this? All right. Let's get started. So thanks again for coming back and joining us. My name's Steve Boisvert. I'm with Auros Knowledge Systems. And what I want to take you through is actually the meat of the project, and give you a little overview of some of the challenges we had to overcome. And I'm going to take you through what was developed, and we're even going to talk about some of the things that we investigated, but and looked into, but things that we ultimately realized didn't fit the scope of the project. To give you an idea, things that are capable of being executed within the tool set and things that currently aren't capable. And then I'm going to follow that up. We have a few use cases we're going to go through. We're going to look at some of the way the functionality is applicable within ShipConstructor and how it all works together. And then we're going to follow that up. I think I'm going to do a live demonstration to show you how it starts from, start to finish. We're going to go through and see how we're going to create a knowledge packet, how that flows into checking something within the 3D model. And then we'll open that up for questions. And if throughout this part of the discussion, you have a particular topic of interest you want to, to see if this technology could handle, we might even try to do that live as well, depending on what it is. So we'll open it up for suggestions at the end. So before I get started, I want to kind of go back and revisit some of the technology, because this is a critical role in what we've been able to accomplish, being able to talk to ShipConstructor and executing the ABS rules inside of the 3D model. And Greg mentioned these. There's 3 core technologies: the knowledge packet, the assessment control, and the rule processing engine. I just want to give you a little bit more detail of what those are. And so the first thing that we're going to talk about is the knowledge packet, right? And simply stated, it's just captured knowledge. Whether it's an ABS rule or a design for production rule, or just some tribal knowledge that you've captured and you want to execute. They all have a similar template. We have a contextual area that we can define the intent of the knowledge, whatever it is. And then we have the ability to create these things called value tables, like Greg referenced earlier. And for this particular project, this is really important for what we're doing in terms of being able to talk to a 3D application. And in this case, this value table defines that constraint. It's the model of that rule. And even if we don't even read this, the textual area of the rule, we can see that it's talking about this thickness based on a certain deck type. So there's some inputs that we need to know. What's the deck type? What's the spacing? What's the length of the vessel? And then based on that, there's some conditionality that invokes different rules. And you can see all these result in these little green parameters down here. And I'm going to show you how these green parameters are the items that get passed between Auros IQ and ShipConstructor. And these are the things that allow us to rule process these parameters inside of the 3D model. And the way we're going to do that, we're not just going to pass the knowledge packets themselves. We could do that, but when we talk about this project, one of the things we need to focus on is we needed to be able to deliver objective quality evidence that the rule was met. And the way we do that is through this thing called an assessment control. And that assessment control is really the brains that says, you know, for this particular operation, you're in the midship, and you know, you're working on structure, you know, maybe it's deck plating and whatnot. The assessment control is the brains that says, here's the context of what you're working on, and it goes out and harvests all the relevant knowledge packets related to that context and brings it to you. And you can see there's a collection of knowledge packets here. Each one of these lines represents a knowledge packet. So for this project, these are all ABS rules. And this is actually deck rules that get brought in. And what happens is, as we utilize these rules, we have traceability that those rules were utilized for a particular project. And when we connect these rules to a CAD object, or either the drawing or a part within that drawing, then we have traceability from the assessment control to that drawing or the part within that drawing. And we can, you know, make those connections to see, oh, okay, the thickness is a result of this particular part within this drawing. And we can trace that back, and we can see those values, where they're coming from, what was the model and such. So the assessment control not only collects the relevant knowledge packets, but it stores the information of how that knowledge was used on that project. And there's different ways we do that. So the first view is like a line item view. If we strip out all that text about what the rule is, we want to just see the parameters, then, you know, a different view of that same information is shown here, where, you know, all we're looking at is those parameters that were in those value tables. So when they're connected, you know, to a 3D model, and those values are being passed back and forth, these are those values that you're going to see, and you can see how the values that are passed are either compliant or not compliant to the rule. So it's a little simplified view here. And the rules engine is really what does that. It makes that connection to, allows us to connect the rules and allows us to process the values for those parameters. So when we talk about connecting to another environment, you know, whether it be CAD or a PLM system or CAE system, whatever happens to be another environment, there's some core technology there. It's all web services. There's basically little routines that run that allows us to collect information from, in this case, ShipConstructor, right? That's what we have on the left-hand side. ShipConstructor is going to define the context. It's going to tell us, I'm working on this deck, or, you know, I'm doing an inclined ladder study, and we pass that information to Auros, where Auros is going to say, here's the relevant knowledge related to that context. And once it gathers up that relevant information, if you remember those value tables, all of the information that it gathers, it'll look to see any of those that have a value table, and it'll take those value tables and extract those key parameters from in those value tables, and it's going to want to pass those values back to the modeling tool, right? We want to be able to store those key parameters in that modeling tool, that way we can get the values from that particular drawing or part, you know, whatever that model is. Because once we've made a connection from the modeling environment to those parameters, we're going to pass those values back to the rules engine, where the rules engine is going to process those values and say you're either compliant or you're not compliant to that the rule or specification or whatever it happens to be, right? And we're going to be able to process that and then send back into the application an indication whether or not you're either passing or failing or whatever you're doing to that rule. And in the background, all that information, right, is stored inside of Auros. So those values that we're passing in to get rule processed, we're able to see that, track that, have, you know, historical record of what those values were. So if we ever need to go back and see, you know, the changes over time, or maybe what how one particular rule was processed on this project versus this project, we have that historical record and that traceability that we can go back and review that information. And out of that, we can generate all sorts of reports. So in general, this is how it's going to work. We're going to get information from ShipConstructor. We're going to collect the relevant knowledge. We're going to pass the parameters in. We're going to connect those parameters to information in the model, and then it's going to get rule processed from there. So to make that work, we had to develop a connector, right? We had to use web services to create a connector that allowed two applications to talk to each other. And what you see on your screen here is the connector itself. And you can see there's a 1, 2, and 3. Because the connector has 3 primary locations where we need to enter information. And we're going to go through this, and I'll show you this a bunch of times. But first, the first primary thing we need to do is, define some settings. And then this is where we're going to attach it to, an assessment control or a collection of knowledge. And that collection of knowledge is going to then result in some parameters, which is the middle section. And then once we have those parameters in the model, then we'll be able to rule process. So there's 3 primary steps that we're going to go through as we look at some of the examples to this. Now, the big challenge that we had on this project while I'm on the screen is we have an application that does 3D modeling really well. And we have an application that creates these executable rules and parameters really well. But underneath all that, we had this foundational application that really had no concept of, 3D parametric modeling. The concept of parameters inside of the AutoCAD 3D model just wasn't there. So the first hurdle we had to overcome is, how do we get these parameters stored on the drawing or on a part within the drawing? And so we developed some technology where we can now take the parameters from the rule set and store it either at the drawing level, so the overall drawing, or on a specific part within that drawing, and then have those parameters stay persistent, so those values remain once we save that drawing or that part. So the next time we come in to rule process, those values are still there. So that was a big hurdle we had to overcome right off the bat with this project. And so once we were able to overcome that, what we had to do was provide a way within the modeling environment to take these parameters that exist in the rules and allow us to link those parameters to different aspects of the model. And so what we have here is the parameter palette within ShipConstructor. You can see across the top ribbon here, we have our Auros menu options. And this little window here is what happens when we want to process our Auros parameters. It brings those in and stores them either at the drawing level or at the part level. And then it allows us to then define those parameters either against a measurement or a property value, or that's kind of about it, or basically some calculation or a manual entry value in some cases. But it allows us to say, in this particular instance, the thickness of plate 1, give it a value. We either manually enter it, or we select a part, and based on the part that's selected, automatically get that value from that particular part. And then we can have that rule process once we have these parameters. So as I mentioned, the particular features we're looking at here are our Auros parameter menu option, and that results once we execute that Auros parameters menu, we get our parameter palette, where then we can enable the Auros Auros ShipConstructor connector, and then we go through our 3 steps there. And as you can see, once we have our rules or our parameters attached to different properties or values, the rule gets processed, and we can see an indication of whether that rule is passing or not passing the intent, in this case, of an ABS rule. So given the values within the model, we can see whether or not they pass that rule. And then we can store that information back to Auros and then provide that information to ABS as an indication of evidence that, a rule is either passing or failing their criteria. And along with all that, being able to attach the parameters and do this and that, we had to have a way to maintain those parameters. So once we're in a model, we're in a drawing, we can see which parts or which drawings have an assessment attached to them. And that's all this little feature here is doing. It shows whether or not there's something there, and we can click on that little link and it brings up more details. But it's our way to kind of visually see within the application, what have I done? Which ones haven't I done? Kind of thing if I'm checking each of these different parts. So throughout this project, once we developed that core functionality and we're able to take the rule set and take those ABS rules and get them into an executable form where they all have parameters, we went in and said, all right, now that we have this functionality where we can take those rules and we can store those parameters against the part or against the drawing in general, what are some of the primary use cases where this might be applicable? And out of that, we came up with 4 primary use cases, and I'm sure there's lots more, but these 4 primary use cases kind of give us a pretty good indication of what's possible with the current connector. And our first use case, we're going to look at something where it involves, basic sizing, whether the rule is an ABS rule or maybe it's an ASTM 1166 rule or, just shipyard tribal knowledge where there's some sizing requirement that needs to be verified in the 3D model. Then our use case 1 is all about those kind of requirement checks. And so what I have here is a little video, and I'm going to play, and I'm going to narrate it, and we're going to walk through how the connector works, and going to see how the measure feature is going to be the key aspect of this particular use case. All right, so there we go. So for this example, we're going to look at side shell plating, and this is the training project in ShipConstructor. And what I've done is I have opened up the Auros tools menu, and you can see our tools all across the top. There's several different ones, but the one we're interested in for this project are the parameters. And once I clicked on Auros parameters, it opened up the parameter palette. And I see this little lightning bolt here where it allows me to connect to Auros IQ and allows me to connect to a set of knowledge, right? So there's rules based on this particular drawing that have parameters, which are shown there as unmatched because they're not in the model yet. And what I'm doing is I'm adding those into the model, right? The drawing didn't have those parameters. I told the connector to add them to that drawing, and that's what you see here. So once I have them in my drawing, then what I have is I store that against the drawing, but I also have access to the specific rule itself. So what I'm going to do now is I'm going to open up the knowledge packet to give you an idea of what we're going to check. In this case, it's side shell plating. So this is out of the ABS barge rules. And the knowledge packet for this has a value table, and it results in these parameters. And what I'm doing now is just kind of giving you an author view of showing how this rule will get executed. If I know the length and I know that frame spacing, I can calculate what's required for that side shell thickness. And given a value from ShipConstructor for the actual, I can compare that and I can see whether I pass or fail. So inside of the model now, or the drawing, I can see that I have this little broken link inside of my rule processing engine side. And it's showing that these are not connected to anything into the drawing. They're part of the drawing, but they're not connected to dimensions of any or any kind of attributes. So what I'm going to do now is I'm going to take those parameters and I'm going to connect them either to a measurement, I'm going to fill them in by hand, or in some cases like this actual side shell value, that's an attribute value of that plate. And so I can tie that parameter, side shell actual, to the stock thickness attribute, which you can see here. And that gives me my value. Once I have all of my parameters connected to information in the model, that goes off to the rule processing engine. And then that rule processing engine sends back an indication whether or not I passed or I failed that rule based on information that was provided to the rules engine from the drawing. And that's what we saw right about here, where we saw the reds, this red indication. And we can see what's calculated within the rule. So in this case, my required was 12, but my actual is 10. So that's why it's failing this particular rule. And actually, if we scroll over a little bit, there's actually a little message that tells me that says, hey, your required value is this and your actual is this, hence it's failed condition. But what I want to focus in on here is we used a few different features to rule process. We used a measure where we're able to go directly to different points of the model, or the drawing, and attach a measurement. In this case, it was for frame spacing, and we measured, and it was 553 millimeters. And we provided that along with the length of the vessel to indicate which rule we need to use. And then we used a property, we used an attribute value on that plate thickness to determine what our thickness is of that plate. So I didn't type this in. This was a property value that we're able to reference. Pass that in, and that's where we can calculate what's required. So this is calculating that ABS rule, and then looking at what the actual value is and seeing if it's sufficient or not. And so we can do that with an assortment of rules. It doesn't necessarily have to be ABS rules. It can be any rule that requires some sort of a measure, right? We can use these measure functions to then verify whether we're compliant or not. And then we can store all this and then send this off as part of an assessment control. Oh, wrong button. So use case one, basic measures, right? So maybe this is the size of a cutout, plate thicknesses, I don't know, the height of a guardrail. I'm not even sure. Some of the examples you might get, anytime there's a measurement, a reference to a size, this is a pretty good use case to verify within the 3D model. Now, our second use case that we're going to look at, this one actually came from Charlie. So Charlie said, one of the things that we do is we don't really check until it's in 3D are things like our incline ladders, because on the scalings, they're flat and there's an indication that there's a ladder there, but it gets modeled after the fact and we have to go in and verify it. So it'd kind of be nice if we could check some of those rules in the 3D model, and how could we do that? So this example, it's going to utilize a lot of that same functionality we looked at in use case one, but this is an example where we can look at a little bit different aspect of our measure, because this one requires an angle. And I like this example because there's some subtle differences between what we did in use case one and what we would have to do here to verify these incline ladder requirements. Now, these aren't ABS rules. This is these rules we got out of ASTM 1166, but still very similar. We took a rule set and we codified it into knowledge packets, and we created those little value tables that have parameters, and then we're going to pass those into this example. So here's use case two. So again, we have our Auros menu open. We're going to go to those parameters. Now, this time I'm on the drawing. I wasn't on a particular part, and you can see I'm on a drawing based on what's here and what's listed here, connected to CAD model, and it says drawing. It doesn't say this particular part. And in this one, I'm going to go off and tell it I'm going to use the metal outfitting rules that I created for this example. So this is what's going to go and say, all right, I need these knowledge packets. And I'm going to grab the knowledge packets that I need for inclined ladders, which results here. And what happens is it says, for those rules, these are the parameters that are related to those rules. And this is showing me those parameters, and this is where I'm going to add them into the drawing. So now they have been added to the drawing. And if I do a little update, you can see that they're in my parameter palette. Now again, they're not attached to anything. They're just there. So they're parameters that are stored against the drawing, but they're not linked to any dimension or to an attribute value. And so one of the things that's useful again is if I want to know how the rule needs to be used. So if I want details of that rule, again, there's a quick link to get me right to that knowledge packet. And you can see the value table for this one. Actually, I'm going to pause it right there. So the value table for this one has some conditionality of the type of incline that's required. And we're going to detect some of this information from, well, actually, we're going to define this, but we're going to look at how we can define the type of equipment we're being used. So kind of a conditionality. And then we're going to look at the angle of ascent. So basically, how steep is that angle? And then based on that angle, we're going to get a indication whether that's will pass or fail based on these preferred and not preferred zones, which all basically came out of this image out of ASTM 1166. So this is how the knowledge packet is going to process. We're going to look at that by clicking on the little lightning bolt, and given the the equipment that we're going to use, so we're going to use an incline ladder, and if that incline is 50 degrees, we're good. If that incline that we need is 65 degrees, that's not preferred. If that incline is 70 degrees or above, then it's a safety warning, and you're going to see here. And so again, this is kind of a way for the author to kind of check that rule to make sure it's working correctly before we put it into a model. And so now that I know about that rule, I can see my little broken links there. So these haven't been attached to anything. So this is the information for me to go to the parameter palette and start to connect the parameters to objects in the model. So in this case, what we're going to do is before we can actually run this particular rule, we have to change the UCS because this requires an angle measurement. And if we're not using the proper UCS, we're not going to get the proper angle. So the first thing I'm going to do is set my UCS based on that leg of that incline ladder. And then now that I have that set, I can click on my parameters. You can see those parameters pop right back up because they're stored against the part, or they're stored against the drawing. I'm going to define my equipment type. I'm using an incline ladder. I'm going to run my measure. This time I'm going to run an angle, right? And we're going to look at the angle of this leg compared to the deck. So I'm going to select that leg, and then I got to select the reference line for the deck. And then from there, I can get my measure, or my angle measurement, which is then stored against angle of ascent. And you can see it's 59.31 degrees. That's how Pat David, that's the incline ladder he liked, and that's one that he modeled. And he wanted it at 59.31 degrees, which ends up actually passing that rule. So the equipment type rule passes now that we know that it's an incline ladder and it's at 59.31 degrees. But there's two other rules, right? We're not just checking one, we're checking three. There's the riser height and tread width still need to be validated before we can say that this incline ladder is any good. And so again, I can just use measures. We're going to look at just one of the risers. Ideally, we would have instances for each riser, and we can check each one of those steps. But we're going to look at worst case. So I checked the worst riser, and I checked the typical tread width. And you can see I did that through a CAD measure. And then now that I have these values, I can rule process those, and then that's going to open up here in the connector and show me whether or not I passed. So our angle of ascent is good, but our riser height is really bad. And our tread width isn't correct. And so again, with that information gets stored, and we can pass that information to whoever, because it's stored in the assessment control. We can provide that as assessment control as evidence that links back to that drawing or that part. So we can provide those to, to ABS or whoever needs to verify that information. So that was use case 2. So use case 3 came from us from ABS. So one of the things that came out of the project was, Juan Min said, can you use this functionality to check welding? And we said, well, I don't know, but we'll figure it out. So turns out we can. And this use case is going to show how it doesn't necessarily have to be, a plate or a stiffener, that we can gather information from even weld objects and run these calculations. So we're going to play this use case 3 video. So this starts out with the training project again, and we have a drawing it's all around welding. So we have this panel with some stiffeners, and the items in red are the weld objects. And in this one, we're going to start with, we already have the parameters. So we have the parameters added to the drawing. We're connected at the drawing level. You can see that up there. This is an example of one of the rules. So it's talking about some T-joint boundary connections. And if we know the thickness of 2 plates and the weld thickness, we can calculate whether or not we pass or fail that rule. And so again, I'm just testing the rule as an author to make sure it's functioning. So you can see I've put in some sample plate thickness values, and I entered a sample weld thickness value, and it came back with a result. So the rules is working as I intended it. So now in the model, I'm going to attach those parameters to, in this case, a couple different plates. So I'm going to use a property value for plate 1, and I'm going to select this vertical plate. And to get the thickness of that plate, I'm going to choose its stock thickness, because that's the attribute value that's related to that thickness value. And the second plate, I'm going to choose this bigger plate here, and we're going to relate that to stock thickness. And you can see that there's 2 different sizes, 8 millimeters and 11 millimeters. And to get the value of the weld, I can select that weld object, and I can tie that right to the weld thickness. And I get 6 millimeters. And I actually have a second rule in here that talks about some overlap. And I'm going to use the measure function to just do a quick measure to get that overlap value. Well, a value. So now I have all of my parameters attached to objects in the drawing, and those get sent off to the Auros IQ rules engine, and I can see how those rules get evaluated here in the parameter or the connector. And in this case, I didn't do so good on my rules, and I have some failed welding requirements based on my rules. And again, that's all stored in the assessment control and can be seen here, where I have some rules, and then that can be passed to ABS as evidence of meeting or not meeting that rule. In our last use case, we're going to look at was one where we actually had intentions of doing more. We're going to get into this a little bit here in a second. We wanted to look at global section modulus, like at the midship section. And as a result of that, we couldn't do, well, we'll get into that part of it, but what ends up happening is we had to be able to solve whether or not we could do a local section modulus calculation before we can solve a global section modulus calculation. And so our use case 4 is just showing our ability to utilize the knowledge packets and some of the calculations that occur within the knowledge packets, along with some information in the drawing, to determine whether or not we're meeting section modulus calculations. And for this example, we're just going to look at one stiffener and look to see whether or not that one particular stiffener is meeting its section modulus requirements. So we're going to play a little video. So in this case, I have a deck drawing open. I have some stiffeners here. I have this L stiffener. And we're going to start this where I already have the parameters attached to it. And in this case, I have several parameters in order to be able to calculate the required section modulus. And if we look at the connector, you can see there's a lot of parameters to determine a section modulus value. Right, so this is the assessment control that's showing just the parameters for section modulus. And to calculate it, we actually need two knowledge packets. The first knowledge packet is going to define the rule for that stiffener. So this comes from ABS, where it's going to define that rule. And in this case, it's this stiffener requirements for a watertight bulkhead, but it could be any number of the section modulus ones. This is an example we used. And in this one, you can see I'm checking the rule. So there's some conditionality on the type of bulkhead. What's the height? What's the frame spacing? What's the length? And then once those values are known, then there's a calculation that happens where I can determine what the required is. And then we need to figure out what the actual is. And to figure out the actual, we actually need a second knowledge packet to do that. And we're going to use the two knowledge packets together where we can compare the value from one knowledge packet to another and then get us a status. So this SM actual actually comes from a calculation sheet provided to us from Charlie. So based on an input of the type of stiffener, what's the shape of that stiffener, what's the frame spacing, and what's the plate attached to that stiffener, we can determine what that section modulus is for that stiffener. In this case, it's a parameter that resulted, and that one was 16 was the value. So we're going to do the same thing in the model. I'm going to kind of shortcut this example a little bit because I don't have all of those input values as attributes. So some of these I got to manually enter, like the height. So if there's an attribute for height or length or whatnot, we could attach those. For this one, we're just going to either do some measures or I'm going to fill this stuff in. And that's what you're seeing here. And in this case, I'm going to measure the plate thickness. Could have done that from the properties. And I also could have gotten the shape from the properties too. If shape parameter was also the shape attribute name. But in this case, for this particular example, I'm just going to select it. And then based on that, now that I have a value for all of my inputs, I can calculate what my required is and then compare that to the actual. And then I get an indication of whether or not I'm meeting that particular section modulus calculation in my drawing. So those were the kind of a summary of 4 different use cases that came out of discussions with the shipyard of potential ways to utilize this type of functionality, and ones that we actually had models for within the training environment that we could simulate some of these use cases along with having rules to apply to the drawings within the training environment, because that's what actually all I have on my little machine here. So hopefully you get an idea of kind of the flow of the transfer of parameters from the knowledge packet to the connector into the drawing, and then the ability to attach those parameters to objects in the drawing, and then have a rule process. And actually, I'm gonna do one of those live start to finish, even starting from creating a knowledge packet here in a minute, just to give you a little bit better idea and not show you in a movie, but show you in live how it's done. Even though that's probably not wise because Murphy's Law, something's probably going to happen, but I'm going to try it anyway, and we're going to just see what happens. But before we get to that, before we kind of do one live, I touched on a couple things. One of them was some of the things that we wanted to do in the project, but they either fell out of scope, or there's functionality that just didn't exist yet that we couldn't utilize or couldn't get developed in time in order to include it in this project. And see if I can get this to move. The first one of the first use cases both shipyards came to us and said was, you know, it'd be great if we could take our scantlings and the values within the scantling drawings and verify those values in the 3D model. And we looked long and hard at this particular problem. And one of the things that we found was in its current state, it's just we weren't able to provide this kind of functionality. And it basically boiled down to, because the scantlings are lines that don't necessarily get associated to the 3D object. So a line inside of the two-dimensional drawing doesn't know that it's a line in a 3D model. There's just not a relationship there. And we looked at putting different attributes together to make it smarter. So a particular line would know that it becomes part of a 3D object, where then once it's part of a 3D object, we can compare the attribute values in the 3D object to the attribute values in the 2D object. And it became a very difficult task to try to even comprehend where we would start with that, because we have the lines, then we have certain dimensions, which are just text boxes, which the particular value for that particular line or object is just text. And it kind of ballooned in scope to the point where we couldn't contain it as part of the project. And we had other use cases to focus on. We had other functionality that needed to be developed in order to even put parameters inside of a 3D model. Putting parameters on the 2D object to then verify in the 3D model just kind of was too much for the particular project. But we took a long, hard look at this, and as a team, we said, it's just too much to handle for this panel project. The second one that we spent a lot of time on was global section modulus. So, Juan Min from ABS said, it'd be great if we could check that global section modulus and compare it to our rule, especially, for a midship. And how can we do that? And we looked at it long and hard of different ways where we could get property, mass properties from AutoCAD, and try to compare that to things we know and summarize the section modulus. And again, it kind of became this big effort that we weren't really sure we could contain in the amount of time that we had left, once we had the core functionality in place. And so we decided we needed to figure out whether or not we could even calculate a local section modulus before we can spend time determining whether we can do a global section modulus. And so with some of the last few weeks of the project is where we developed the capability to look at a shape of a stiffener and determine its actual value and compare that to a rule to see whether or not we're meeting local section modulus values. And the global section modulus capability just, again, fell out of scope. So what I want to do now is I want to show this, take a different approach and not just show you a video. I want to open up ShipConstructor. I'm going to open up Auros IQ, and we're going to create a knowledge packet to show you what's involved in that, because we started, I started my demonstrations of there's already knowledge captured, there's already rules provided from ABS or whatever that result in these parameters. And I just kind of shown how they get plopped into a drawing and we attach things to it, and then everything shows up green or red or whatever. But I want to give you a better understanding of what is the level of effort involved to make that happen, start to finish. We're just going to do one rule, but I want to give you an idea of the level of effort. So for that, we're going to hop out of our presentation mode here, and I have a drawing open. So this is, again, the training project within ShipConstructor, and you can see there's Pat David's sweet little incline ladder sticking out over here that we had in our demo. But we're going to create a rule. And
I'd like to break in with just to clarify, that is not an incline ladder I would make normally.
Well, you made it.
I know, but you're going to give me a bad rap. This is a test case, people.
Well, it's a test case, and it was a test. Yeah,
that's right.
So looking at this particular drawing, I thought, you know, what kind of rule can we do? And I'm just thinking about something simple that we can kind of do to see start to finish how we're going to do it. And I saw this little cutout here, and I thought, you know, if kind of we'll make a rule for maybe there's a requirement that this cutout has to be a certain size, and so we're going to start there, right? So there's currently not a rule, and I haven't created anything yet. So to do that, we're going to start from Auros. So I have our NSRP instance of Auros open, and I'm going to go to our workshop connector community of practice, and it's going to start here. So I have one knowledge packet in here that's really nothing, and I'm going to create a new one. So we talked about this capture knowledge in these knowledge packets, but I wanted to show you how to do it. So I went to create new, and we're going to call this let's see, deck cutout. Let's make it simple, right? And we're going to give it a description, required deck cutout width, right? Pretty simple stuff. Now, all this is right now is text, right? So if someone came and looked at it, they're going to say, all right, deck cutout, required deck cutout width, what is it? I should have put in a value here, but I didn't think that far ahead. So we're going to put it in the value table. So here's where we create the brains of the rule, especially when we're going to connect it to you know, a model. So we're going to call this, again, cutout width, and we need to get a parameter. By default, I don't know if you guys can see this, but by default, it gives it whatever the knowledge packet name is and a parameter name here, but that's not going to mean anything to us when we're in the model. So we're going to call this cut out width, right? Continue. And I have to define it. What are my units? Well, to make it simple, our model is in millimeters, so we're just going to say it's millimeters. And I'm going to say this is a minimum. So we have all these types. So we can say it's a nominal or max or minimum or expression or derived value, a whole bunch of different types of value tables we can create. We're going to keep it simple. We're going to say a minimum of, I don't know, 500 millimeters, right? So cutout width parameter, its type is a minimum. I have some units and I have a value. Apply that, and I'm going to save it. We're going to make that active, and kind of following the theme of the videos, we're going to look at this particular knowledge packet. So now we have two. Here's workshop 2, required deck cutout, required deck cutout width, and to check it, cutout width, if I give it a value of 250, so if I connect it to that cutout with a measurement and the value is 250, we're going to fail. If the value is 501, it's going to pass. Pretty simple. So simple rule. All right, so we're going to go into SHIPConstructor. So now I have an executable rule. We're going to go to SHIPConstructor. And when I open up SHIPConstructor, I don't have my Auros menu here. So I'm going to go to the right. I'm going to tell it to go to Auros. And that opens up all of my connector options. And again, we want to connect this to that cutout. So we're going to use a parameter. So if I hit this little Auros parameter, then our parameter palette opens. And you can see there's nothing attached to this drawing yet. And it's at the drawing level. You can see that here. And what I want to do is there's that little lightning bolt. I'm going to check the rules. So if you remember the way I started, it starts 3 primary things I got to execute. I got to define either the assessment control that's going to collect the knowledge packets that I want to apply, or I can go and just choose those knowledge packets. And that's what I'm going to do for this example. I'm going to tell it to go to our workshop. Where's our workshop? Connector workshop. And we're going to look at our workshop example. And I'm going to load it. So what's happening now is it's making that connection to Auros IQ. It looks at that knowledge packet, because there's only one in there, well, one with a value table. And it's saying, all right, here's cutout width. But cutout width isn't part of our drawing. So I'm going to link that into the drawing by saying create unmatched parameters. And this little window allows me to either create one parameter, or let's say I need to do a cutout width. Maybe there's 3 cutouts. I could use that same rule and instance that rule 3 times, and then measure 3 different cutouts, and then check those 3 cutouts against one rule. And that's what this is allowing me to do here, but I'm not going to do it because we only have 1 cutout, but I could create several instances of that rule. And so I'm just going to say create it. And you can see down here, so let's close this window. You can see it's cutout width, and I don't have it gives me this little broken link. And if I refresh my view here, cutout width now shows up as part of my drawing parameters. And there's no value, enter a number. And it knows that it's in millimeters. And now I have the opportunity to use my measure feature, right? I'm going to measure a distance. And we're just going to say it's from this corner. Zoom out a little bit to whatever, this corner. And I get the value from the model. It's telling me I'm getting it from a CAD measure. Right? We're going to publish that. And we're going to look at the rule. So now I have this value, 1043. I sent that back to Auros IQ. The rules engine processed it and said, the calculated value I need is 500. The model value is 1043. Therefore, I get a pass condition. And that's how the rule processor works. So now let's go one step further. So I'm going to just say, okay, we're going to close that. And we're going to leave this open. And we're going to go back because maybe we also need the width. So let's kind of go back here and we're going to edit this. And someone comes along and says, well, that's great that you have width, but we need the length. So we're going to add another parameter. We're going to add a column for cutout length. And we're going to name this guy the same. Again, this is going to be in millimeters. Let's do a maximum this time. And let's say the maximum is, I don't know, 1,000. All right, so now we have 2 parameters, cutout width, cutout length. We're going to apply that, save it. So now our knowledge is updated. We have, there's some knowledge on what our cutouts need to be. And then now we're going to come back to our model. Let's come back over here. We're going to open our connector. And as soon as I open my connector, it tells me, hey, there's a new parameter. So this stays connected to Auros IQ and it's constantly looking for new parameters. Even in this case, it also looks for new knowledge packets that match, this criteria. So as I created that new parameter, so let's say there's new knowledge being developed, it's going to show me here. So I have this cutout length. I'm going to add that into my model, right? Apply that. So that's going to get added in. You can see again, I have the little broken link down here. Do a little refresh in my drawing. Cutout width, cutout length. Let's do a measure. Distance. I don't know. Pick there and say whatever right here. So we have 1,706 millimeters is the measured value that I have. If I process that, open it up, because I had that maximum condition, and my maximum was 1,000. We have 1,700. I get my fail condition. And I could save all this inside of an assessment, provide this to, you know, whoever. It would have information about my model in here. All of these parameter values are stored against the drawing because that's what I've defined it as here, as user-defined attributes. And so the next time I open this drawing, I'll have a reference that, oh, I've already, you know, applied these parameters to this drawing. I've applied this assessment to the drawing, and these are the values at that time when last time I ran my particular rule check. So hopefully with you know, the use cases that we went through in this, you know, brief live demo, you get an understanding of kind of really the intent of the project. And again, a major challenge was just even being able to get these darn parameters into this environment and have them stay persistent and stored against either the drawing or the particular part that we run these rule checks on. So with that, I'd like to open it up if there's any comments, if someone has a particular example they would like to or a request for something that they would like to see. You know, maybe we can create something quickly, or if we have the right training model, we could execute it. If not, you know, if there's anyone that has questions, I would be happy to answer any of those questions as well.
I had a question, Steve. If this is
Yep.
Jason from SSI, if you've used the plate parameter in one of your rules, like stock thickness, and then that plate changes to be a different stock, does that parameter update?
Yeah, that's a good question. And the answer is it can. So the way actually that particular use case that we ran through was, I think it was in the welding one. And the way I had it defined, if the stock thickness changed, it wouldn't know, because I named the parameter like thickness or plate thickness, and then the parameter for that plate was, you know, stock thickness. But if I would have named that parameter stock thickness, and the attribute for, well, that attribute for that value is stock thickness, then we have a parameter pair. They match each other. And so as things change, the value gets passed, because the parameter is named the same as the UDA, it gets passed through the rule processor, and then that value will update the next time I execute the connector. So the issue is from naming. In our demonstration names from our parameters didn't make. I actually probably should have done a rule set that had some UDAs that matched the parameter names. Any other questions? Any feedback? All right, well, that was pretty easy then. Hopefully you guys learned something new today, and if you can think of ways that you may be able to utilize this functionality, please let us know. We'd be happy to talk to you more about it. And with that, I'm going to stop sharing, Pat.
Thank you, Steve. Great job.
Thanks.
Fantastic. I mean, sort of fantastic. I've been watching this, so it's less than stellar to me because I've watched the evolution of it over the course of a year. But hopefully the people watching for the first time, or really kind of getting a look at it for the first time, appreciates just how cool this is, because it's really the first steps to being able to deepen that integration, right? So we are in a good place. And so nobody has any questions. I don't actually remember what was on my agenda. I guess I should look at the slide deck. Oh gosh, there wasn't a whole lot left.
That was it.
Wow, you guys are good. You guys are good. Let me get my screen shared here. There we go. And that's where we left off with Steve. Any questions? And nobody has any questions. Now, the problem, I guess, is I don't know. I haven't been. Eric, are you monitoring the questions and hand raising, or I don't know if anybody has?
I haven't seen any, Pat.
Okay. Well, okay. If nobody has any questions, then, if you want to learn more or find out anything else about what's going on, in what we've accomplished in the project, what we've looked at, how we've approached it, how you can use it yourself, or any suggestions on use cases, this point of contact slide will be in the presentation, which I believe we're going to make publicly available after this meeting. So by all means, hit up the NSRP.org website for this project, and you'll be able to find our contact information here. So you don't have to be furiously trying to scribble it down or writing it down right now. And on that note, oh, look at that. Oh, an easy one.
Have a great
Well
day.
done.